Spring has arrived, bringing warmer days after an especially bitter winter. This raises a question often asked around the world. If global warming is real, why are we still getting hit by such extreme cold snaps? The reason is not just simply a change in weather. It has to do with shifts in the structure of Earth's atmospheric circulation. Today, we will explore this question through concepts such as the Arctic Oscillation, the jet stream, and Arctic amplification. The Arctic Oscillation and the jet stream, an invisible wall that traps cold air. About 10 kilometers above the northern hemisphere during winter, there is a fast-moving band of wind called the jet stream. This powerful wind wraps around the cold Arctic air and prevents it from moving down into the mid-latitudes, which are the regions between the equator and the Arctic. A vast pool of freezing air, called the polar vortex, sits above the Arctic. The jet stream usually acts as a wall, keeping that cold bottled up. The strength of this defense line is explained by something called the Arctic Oscillation. When the temperature difference between the Arctic and the mid-latitudes is large, the jet stream flows quickly and in a relatively straight path. This is called the positive plus phase of the Arctic Oscillation. During this phase, the cold Arctic air stays in place, and winters in many regions are milder. However, when the temperature difference becomes smaller, the jet stream weakens and begins to bend in large waves. Through these bends, cold Arctic air can spill southward, causing severe cold waves. Arctic amplification and a wobbling sky, changes in atmospheric flow. The Arctic has been warming at a rate several times faster than the global average, a trend scientists refer to as Arctic amplification. As reflective white sea ice continues to melt, it exposes darker ocean water beneath. Unlike ice, the darker surface absorbs more of the sun's heat, accelerating the region's warming. Researchers say this feedback effect is causing the Arctic to retain more energy and warm at an increasing pace. As a result, the temperature difference between the Arctic and the mid-latitude regions is gradually narrowing. This temperature difference is what drives the jet stream. When the difference decreases, the jet stream slows down and begins to swing dramatically north and south. When it dips far to the south, it allows Arctic air to extend into lower regions. Global warming does not directly create cold waves. Instead, it changes atmospheric circulation patterns, which can influence extreme cold events. Not every winter becomes colder because of global warming. Overall, the number of cold wave days is actually decreasing in some areas. However, weather variability and extremeness are increasing. There are increasing examples of cold waves becoming stronger and lasting longer when they do occur. Scientists have a name for this era we're living through, the Anthropocene. It's the geological age defined by humans reshaping the planet's fundamental systems. Which means cold snaps and heavy snowfalls aren't just weather, they're tied to the choices we make and the future we're building.